Hey everyone, this is Matt with Learn Everything About Design, and in today's video, which is sponsored by PCBWay, we're going to talk about or finish up the KTM kickstand project with our metal printed aluminum kickstand end. Now, this is actually the second version of the part that I have. The first one is currently permanently attached to the kickstand. So we're going to talk about what went wrong, mistakes were made, lessons were learned, and we're going to talk about the final part, hopefully get it installed after some cutting and grinding, and we'll see if it works. So again, thanks to PCBWay for sponsoring this video. They supplied the parts for me, no charge to me. There's no affiliate relationship other than that. They were just nice enough to sponsor this project and help out. The project, which we went through, we scanned the original kickstand. We talked about what we were doing. We're cutting it shorter because it's just a bit too tall for this bike. It's a KTM 450 SXF. There are not many kickstand options on the market. This is pretty much the only one. And two of the common problems that are, plague this specific kickstand. One was the kickstand foot hit the airbox or the number plate on the side, which is one and the same on the KTM. And two, it was just too long. This bike actually has a shortened rear shock to change the angle of the bike, and it just made it so that I couldn't use the kickstand at all. It would tip over. So I wanted to shorten it up, but since I have 3 sets of wheels for this bike, I've got some off-road wheels, I've got some dual sport wheels, and I have a set of supermoto wheels. I really wanted to have a kickstand that could adjust and work in all those different positions. So what I ended up doing was cutting off the end, which we talked about in our really in the third video, which is this video. I cut off the end, and that was the plan all along, to use the original geometry that was created and add a new feature, add this part on. I tested a 3D printed version, it worked great. I made some adjustments to it for metal printing with PCBWay, fired off the print, got it in, and it didn't fit. Now, there are a couple reasons it didn't fit. The first reason is that I really didn't consider how tight the tolerances were. I knew what the tolerances were on the metal 3D printed part. It was plus or minus 0.3 millimeters, and I kind of hoped to keep it a pretty tight fit. There are some other issues that we ran into when we were reverse engineering this, mainly that this is some raw bar stock. They ran a fillet tool on the edge, which when we went through the process of converting the mesh to a solid, we noticed that the radius is actually different on 2 of the corners. It's 2 millimeters on 2 of them, 3 on the others. The recess or the slot on the top or the front and the back are in different positions. They're slightly shifted. And all of these things were compounding issues. So what I actually figured out when I got the part in is that the physical part that came in was pretty close to the original size. It wasn't under by that 0.3 millimeters, but there were a couple of other issues. One is that the bar stock was not perfectly square, and the fillet tools actually ended up leaving little lips on the side. These weren't things that I caught through the scanning process and reverse engineering process, and just tossing a set of calipers on to get a measurement really didn't give me the sort of scope of the problem that I was dealing with. So that was one issue. I tried to fix it by grinding off the outside a bit and smoothing it down. The second issue was, again, those offset slots, those grooves. The fact that the tolerances on the 3D print were tight and the slots were offset, it was just binding in all sorts of different areas. So that presented another problem. Again, I got around it sort of by grinding and getting this thing installed, lots of hammering. I only hit my hand like 3 or 4 times, but it's permanent. I reached out to PCBWay. I said, I filmed the video. I'm gonna go ahead and talk about the problems I ran into. It wasn't anything with the print. It was just my own issues with hoping that the tolerances were a little bit tighter than they were advertised, and not really realizing just how off this was from being a true rectangle or a square piece. And so they were gracious enough. They said, hey, look, if you want to, we'll send you another one. No charge, don't worry about it. We'll send it out. You can do it properly. And I gave it some thought over a day, and I said, you know what, let's go ahead. Let's do it right. I'll cut this one off, which I'm not really looking forward to. And hopefully the second version fits. So the tolerances that we're dealing with on the first version I printed, the part is essentially 25.5 millimeters wide, and the part that I designed was like 25.6 millimeters wide. So I had like 0.1 millimeters. It wasn't nearly enough, obviously. And so the new one I made is got a 0.5 millimeter gap. I got rid of the recess on the inside, on the back side, where the bolt is going to go through. This does cause some potential problems because the countersink can't really be as deep, so the head of the bolt is going to stick out a little bit. Thankfully, the head of the bolt is rounded. It's not really going to interfere with anything. But that does sort of free up some space on the inside for some of those offset potential problems. Now's the part where we get to cut this thing off and hope it fits. Now, I say hope, it should fit just fine, especially since I ground off so much of this, trying to clean it up and round it off the first time. But we need to get it on here and try. Now, unfortunately, this is not coming back off. I actually had to do all kinds of stuff to get this thing on here, and I just had assumed it's permanent. It works great, it works fine with the off-road tires, but it certainly wouldn't work with any supermoto rims on here. So let's go ahead and fix that. Now, if you're curious about the price, in the quote, we talked about this in the second video. This part is about $45. The CNC version, which was 2 pieces, was something like $200, $250. So I opted to go with the 3D printed metal, 1 for cost, it was going to be more economical, and 2 because I was able to get a single end piece without having multiple pieces, gaps, seams, places where mud could collect, things like that. So this was going to be a cleaner solution. Because this part is really only in compression, and because of the way that it's built and designed, there's not really any structural issues with this, especially in the supermoto position, because the internal piece is going to be all the way to the inside. So it's essentially just a foot on the end. In the off-road version, it's, it's again, there's a large chunk of aluminum that sits inside the groove in there. I do need to run a tap through this to clean it up, which I'll do before I install it. But overall, I just thought this was going to be a much cleaner solution to the problem. Keep in mind that $50 turns into $100 pretty quick when you have to ship it across the world, import it into the US, and pay all the taxes and tariffs and things that go with it. So at the end of the day, you're looking at about $100 right now for this piece. And I think the kickstand kit originally cost me about 200 bucks. Somewhere around there. I don't know, it's from Fastway, or it's a Fastway kickstand. I don't know what they cost right now, but so all said and done, theoretically about $300 to get this sorted out and be what we need for our project. All right, so without further ado, let's go ahead and try to cut this thing off. I don't actually have to cut the entire thing off. I'm hoping if I just cut down the back side, it'll relieve it enough. I'm hoping there are some internal stresses that just cutting part of it will relieve it enough that I can slide it off, because it's only about 25 millimeters or about an inch into the 3D printed part right now. So it's not very far. I'm hoping just cutting this section here around the countersink is going to work. I don't really want to do it with an angle grinder. I don't think it's going to be precise enough. So I'm going to try it with the Dremel, which is going to probably burn through a bunch of cutoff wheels, and the old manual way, a trusty hacksaw, if I need to use that. All right, so let's go ahead and get into it. Moment of truth. So, in practice, there we go. Hopefully I should be able to just push it down. Perfect. Now the bike's not going to fall over. And in the up position. So before, I can't see, but this is where the old one was hitting. And it was actually deforming this, but now this one Still hits a little bit. I could bend this if I needed to, but I'm okay with that. Before it was really pushing it in. Beautiful. So once again, this project could have been finished a few weeks ago had I just spent just a little bit more time double checking my measurements, double checking the tolerances. And if I had used the tolerance values that were listed on the PCBWay website, that plus or minus 0.3 millimeters, I could have saved myself some headache. If I had not hammered and ground and tried to make that first one work, I also could have saved myself some headache trying to get it back off. Obviously, using a Dremel to cut through this stuff and hammer it, not an ideal situation, but we were able to get it off, get the right part installed. Now, thanks to PCBWay, I can have it adjusted for this set of rims that I have on right now, which are the dual sport rims. And if I put my Supermoto rims on, I can lower the kickstand so that way it's not sitting upright and you know, possibly tipping over. I've had that on a couple of bikes that I've done Supermoto conversions on. You kind of always need a shorter kickstand to make that work. This is a great option because it really was the only kickstand available for this bike. So I had either spent a lot of time and effort designing my own, or I go with one that was sort of ready to go and support the company that's making these parts. Now, unfortunately, as I mentioned early on, it wasn't a perfect solution. We did have to make some adjustments. And of course, the last 3 minutes of a video, the microphone dies. But at the end of the day, basically the part works. It could have taken a little bit more time and effort and, you know, accounted for the default tolerances, that plus or minus 0.3 millimeters, which means that the part's either going to be relatively loose or very tight, depending on which direction that goes for the prints. I'm happy with the quality of the 3D print. The tolerances were something that are displayed on the PCBWay website, so it's not like it was an issue with the print. It's just something that we have to account for as designers when we go to make parts fit. Now, at the end of the day, I could have machined an entire piece as a replacement. That would have been another option. But I felt like just replacing the end of the foot, making it adjustable, was the easiest way to go forward, most economical, and most straightforward to design. Now, the entire process takes a bit of time. Obviously, we could have done some of this without scanning. We could have just simply measured. But having the scan as a reference, especially with the angle of the foot and the orientation of the foot, that was all very helpful. So scanning definitely helped out in this scenario, but it wasn't necessarily required to get the end result. Now, if you have any questions on this process, then please leave a comment and let me know. If you want to see more projects like this, little things that I have to do that generally I just do and don't film, let me know that as well. And again, a huge thanks to PCBWay, who offered to sponsor this video and send me the parts for free. Once again, we're not an affiliate, so there is no link, there is no download or discount code or anything like that. But I have genuinely been happy with my own experiences with PCBWay for whatever that's worth for your own projects. Well, so once again, any comments or questions, let me know. As always, thanks for watching. We'll see you in the next one.